Alright, welcome back. We're going to do the second part B of the Intro to Spreadsheets Part 2. And the first part we looked at the built-in functions. Now we're going to look at conditional statements and a little bit, just briefly, conditional formatting. First thing we should probably do is make sure that everyone knows what a conditional statement is. A conditional statement, traditionally, is if, and then if what, then do these things. Okay, so in Excel and actually in several other programming languages, the then is implied. They're assuming that if you're asking the if question, then you're going to want to do something depending on whether the question is true or not. So what I'll do is I'll kind of take you through this a little bit more and give you an example for right now. So we'll look at this later as well. If the speed limit, let's say, is 30 meters per second, we could do something where if the car's speed is greater than the speed limit, then slow down. If the car's speed is less than the speed limit, then speed up. So that's the way that if statements, conditional statements, work. Depending on what the situation is, you have a different action that you take. So this is the way that it looks like in Excel. You type equals, then you type if, and then you have three arguments. Those are the three different parameters that you put inside the parentheses. The first thing is the conditional statement. So that might look like if cell A2 is greater than cell A1. That's the condition. We test that. It's called a logical test. We can then look to see if the result is true, what do we want the outcome to be. So the result, if true, is the output. That's right here. And then if the result of this conditional test is false, we're going to have this as our output instead. So this is what it looks like actually in Excel. And one of the great things about Excel, which I showed you in the last video, is that it provides some guidance when you type in a formula that it knows. So what I'm doing here is I'm just going to compare two numbers together, number 1, number 2, and I'm going to see which one's larger. Not a very difficult thing to do, but I'm going to just automate it anyway. So I have equals if, parenthesis, and then Excel pops up and says this is what can happen. The first thing that you need to do is put in a logical test, comma, and then if that logical test is true, the second parameter here is what you want the output to be if it's true. The third parameter is what you want the output to be if it's false. Okay, so I'm going to show you what that looks like. Okay, I have two numbers. I'll just make this 3 and 6 for now. And then if, and my logical test will be if number 2 is greater than number 1, right, I'll just type out B2 in that case, if it's true. And if it's false, then I'll go with A2 as the output. And there we get the result. And if I go ahead and I make this 9, then 9 is outputted. If I make it 1, then 6 is outputted. I make this 0.5, the larger number is outputted. So each time the larger number is outputted. And that's how that works. Obviously, we could make this more complicated, and that's something that I'll get into in just a moment. But that's the basic structure. Logical test, output if true, output if false. All right, there are 6 basic logical tests that you can perform. 4 of them are on this slide, the other 2 are on the next one. So the first one is just that if I can test to see if one is larger than the other one. This is true if A1 is larger. I can test whether or not they're equal. In most languages, programming languages, you're going to need to use double equal signs, but in Excel, when you're just typing it in as a formula, you just use one equal sign. We can also test to see if A1 is smaller than A2. Very similar to this one, just reverse the order, right? We can also test to see if they're not equal to each other. So this will be true whenever A1 and A2 are not the same. In most languages, this is different. There's normally an exclamation point followed by an equal sign to mean not equal to. But in Excel, it's is A1 less than or greater than A2. And as long as it's either less than or greater than A2, then it's true. If they're equal, then it's not true. And the last two are greater than and equal to or less than and equal to. And so those are the 6 basic logical tests that you can perform as your conditional statement, as the first argument of the Excel if statement. We can also do more complicated ones. So for instance, you could have a test of 2 numbers, and the one that I had done with just the one if statement, it's only going to give me the larger number, but it won't give me an indication of whether or not they're equal to each other. So I might want that. In order to get that, I'm going to need an if statement inside of another if statement. So the first if statement works out pretty much as expected. Okay, I do a logical test. I decide to test to see if they're equal to each other or not. If they are equal to each other, I'm going to have the output be that they're equal. Just going to say equal. However, if they're not equal to each other, there are a couple of different possibilities. A could be larger, or B could be larger. So I can't just output not equal. I mean, I could, but I want to know which one is bigger if they're not equal to each other. So that's where this nested if statement, so it's inside of another if statement, that's where this comes in. If false, if A is not equal to B, then we have to execute another test. And so the test here is A greater than B? If it is, we'll output that A is greater. If it's not, and they're not equal to each other because we've already tested that, that means that B must be greater than A. So we've now accounted for all the different possible scenarios with these 2 if statements, one inside of the other one. And this is just summarizing what I just said as what the outcomes are. So if A is equal to B, we get equal. A greater than B, we get A less than B, we get B. That's the result of this one. If this doesn't make sense to you, you might want to just go and play with it a little bit yourself. Test it out. Try a couple of different things. Okay? Now what I'm going to go and show you now is the example that I had started talking about initially, which is about a car speed limit. So if the car speed is greater than the speed limit, I want it to slow down by a meter per second every second. If the car speed is less than the speed limit, I want us to speed up by a meter per second every second. Otherwise, so in other words, if you're going the speed limit, I want you to keep going the speed limit. Okay, so here we are. I've got a speed limit. I've got different times. And what I'm going to do is I'm just going to enter a value in to start with. Okay, I actually did something a little bit irritating here. I said, Excel, you pick. Pick a number between 20 and 40. So we're going somewhere between 20 and 40 right now. And now what I'm going to do is equals. I want to look at the value that the previous cell has. Oops, nope, if first. So we're going to do a logical test. So if the previous value is greater than, and I want to do A2, and I don't want this to be a relative reference. I want it to always compare to the value of the speed limit. So I'm going to check the cell above this one, which is D2. If it's greater than the speed limit, what I want to do is I want to take D2 minus 1. I want to lower the value. If it's not greater than, then there's 2 possibilities. It could be equal to or it could be less than. So I need to use another if statement to check to see whether this is slower than the speed limit or exactly at the speed limit. So I can say D2, if D2 is less than A2, then if this is true, we want to do D2 plus 1. We want to increase the speed. And otherwise, we'll just keep the speed exactly the same. So if they're equal to each other, we'll keep the speed exactly the same. Notice the parentheses highlighting as I close them. You have to make sure that you close all the parentheses at the appropriate spaces. Okay, now this is kind of irritating, as I said, because this value will just constantly change. The randomness updates each time. So I'm just going to click and drag this down. And you can see here what it did was it started off at 39, and it lowered by 1 every second until we got to the speed limit of 30, and then we were good. Now if I update this, let's say that I update this to 35, so now I've got a speed limit of 35. Well, what's irritating is of course that because it's a random number generator here, went down to 20, right? So it's going up and it's climbing up until it gets supposedly to 35. So let me change this again. I'll make it 32. Okay, so we started at 31, and now we went up until we got to the 32, which only took one step. So this is how conditional statements work. You can do all sorts of different things. I can make this, let's make that 25 for now. And then if I change this to 30, you'll notice that this automatically adjusts to stop at 30 instead of at 32. Okay, this is one of the nice things about using Excel, is that you can quickly play with a lot of different possibilities and see what the outcomes are. Alright, the last thing, very briefly, I'm going to talk about is conditional formatting. This allows you to have the text color, the text qualities like bold and italics, or the cell color, and possibly some other properties, change based on what the rules are governing those cells. So you can have simple rules, you can have complex rules. I'm going to show you where those rules take place and what some of the outcomes might be. Okay, so where to access these rules? You go to the Home tab, you go to Styles, and then Conditional Formatting. That's where they're located. Now I'm going to select these three columns first, and I'm going to go to Styles, Conditional Formatting, and I'm going to do just a very simple thing to start with, a pre-made one. I'm just going to do a color scale, and what this color scale is doing is it's automatically assigning a color based on the numbers, and the larger the numbers, it's making them more green, the lower the numbers, it's making them more red, and so you can see there's a clear, definite pattern. And rather than expecting people to focus on numbers if you're showing them a table, if you show them a color gradient, it's often easier for them to make quick determinations as to what the patterns are. Because we don't actually see patterns in numbers very easily, but patterns in colors we can see pretty clearly. So what I'm going to do here is I'm going to look to see which ones are actually giving me the most variation, which runs. So I'm going to highlight, say, the top three. Okay, and I could change the rules, how it's colored, all those types of things. But this just gives me an indication that, you know what, these three trials were the most variable. I could also say, you know what, I'm interested in ones where we have a value of greater than 0.5, because for some reason I think 0.5 is reasonable, but anything above that is a little bit too much for my liking. So I can see how many there are, I can see which ones they are, I can maybe look back and see, did I do something different with some of these than I did with the other ones that led me to get worse or less reliable looking results. And that's the basic idea between conditional formatting. You can play around with it just like with conditional statements and see how you might be able to use it to help yourself and also to help people you might be presenting to. Although I will caution you, presenting data tables is generally frowned upon unless there's something important about it that you can't show with a graph. And in those cases, I would recommend doing some sort of conditional formatting so that people don't have to think about the numbers, they can think about the colors, which are easier for people to process.